Hey algebra students, we're going to take a look at 510 factoring by grouping. So just as a warm-up, looking at some trial and error factoring. So we would we're going to factor by trial and error factoring. Now the negative in the last term means that we want different signs in our binomials, and of course our first term we're just taking the square root of that, and the positive in the middle term means that the higher factor of 18 that we want to be the positive one. So we think through our factors of 18 and we're looking for a difference of 3, and of course not 16 there. Let's try 6. And that gives us a difference of 3. Now remember, we want the higher one because we want a positive middle term. We want the higher one to, or the factor of 6, which is higher, to go to the positive, and then 3. All right, so that's our trial and error factoring. You can always FOIL to make sure you get to the right product. And then looking at our other example, again, the minus for the last term means that our signs will be different, so that you have a positive times a negative giving you a negative. We want the square root of the first term, and then I want to think through factors of 15. That will give me a difference of 7. Now my factors of 15 and 1 and 15, that will not give me a difference of 7. Then my other factors of 15, 3, and 5, that gives me a difference of 2, and I would think through the rest of the factors, not divisible by 4, not divisible by 5, which is already there. So this is not factorable, or you could write prime. So an important tool in factoring polynomials is really knowing the distributive property and kind of being able to factor out that distributive property in reverse. So when we have the sum and we have that common factor across a sum or a difference, and we can pull that factor out, that is going to be really important for us to realize that we can do. So we're pulling that common factor out across a sum or difference. And we see in example 1, we have that same kind of thing. It's just more than one term. That common factor is x plus y. So looking at that as like that x plus y is like the a in this example here, in that previous example. So we can take that 5 plus w as the one quantity, that's like the b plus c, and we are pulling out that common factor of x plus y. And we can see the same thing in across a difference in example 2. Again, our common factor is m plus 4, and we're going to pull that out. A little difference here is 1, that we have subtraction, and 2, that there is a factor of 1 in there we don't want to miss. So this is m minus 1, that quantity, and we're pulling out the common factor of m plus 4n. You do want to make sure not to miss that you need to put parentheses around both factors. You don't want to change the value of the quantity, so you do need to be careful with that. So example 3, again, we have a common factor. Now the difference here is we have these two are in the reverse order. So if we want to pull out a common factor, we have to reverse the order of that. But if we would rewrite that as a minus 3, of course it would change the value unless we pull out a negative. Much like you can multiply, like if you would do 4 minus 3, you could say that that's equal to 3 minus 4 if you took the opposite of it. So we're going to do that same thing here. We're going to take the opposite of 2a. You kind of pull out that negative 1, and then you can switch those two terms around the subtraction. And then we have a common factor of a minus 3. And so we pull out that common factor. So we have 5 plus 2a all times a minus 3. So now we're taking a look at example 4, and we want to factor this, and we want to be able to kind of pull out a common factor. So you're looking for things that are common between the groups of factors here. And if I group the first two and the last two, and this could take some trial and error as you're working your way through, I look for a common factor between those first two factors, and they both have a 2a in common. So I'm going to factor out that 2a, and that leaves me with b minus 3c in the first term. And in the second grouping, my common factor is a 3. And if I factor out a 3, I get b minus 3c. And hopefully you realize that then that means that there is a common factor between those two terms. Just like in the previous examples, we can pull that out. And so we get that is 2a plus 3 all times b minus 3c. So again, that, those occurring to you and that grouping can take a little bit of trial and error. So we want to look for familiar things. So sometimes you want to look for a perfect squared trinomial. And group 3 terms and 1 term. And so we can see that in this example 5. In example 5, we have these first 3 terms is a perfect square trinomial. So if we group that, we can factor the perfect square trinomial. That perfect square trinomial, because we have a perfect square of x squared, and then we have the minus middle term gives us the minus there. Square root of 36 is 6, and we know that the product of 6x of 6 and x is 6x twice is 12. So that gives me that perfect square trinomial minus y squared. All right. And then hopefully you will notice that that is a difference of squares. And of course, our difference of squares can be factored into twin binomials with opposite signs. Now you'll see I'm keeping that a little bit to the right there because I want the square root of x minus 6 squared, which is x minus 6. And then plus and minus are my opposite signs in my twin binomials, and then the square root of y squared is y. And so we're kind of looking for multiple patterns in here. I know that can be tough, but again, it'll just take some trial and error, and you do need to make sure you're studying your patterns. Right, then taking a look at example 3. This is one where you are looking for a perfect square trinomial, but the trinomial square is second in there, so we need to make sure to do kind of subtraction in reverse. We need to just, much like we did in example 3, we've got to be able to kind of pull out that negative. So what we're looking at is this is the perfect square trinomial, but for a perfect square trinomial, we really want that first term to be a positive. So I'm going to take my x squared, and then I want to say that is, I want to change that to that subtraction so that I can make this first term positive, a positive y squared, but it's really a negative y squared. So what happens is when I change that grouping and pull that subtraction away from the and group the other things, I'm kind of like adding that subtraction into the plus 6, but I don't want to do that without changing the value, so I have to make that a minus 6y. And again, grouping that subtraction changes the minus 9 to a plus 9, so I have to change it to a plus 9 to kind of make sure I'm not changing the value there. All right, and that is that grouping of subtraction you have to be really careful with. Now that does give me a perfect square trinomial, two factors. So now I have x squared minus and y squared minus 6y plus 9 is a perfect square trinomial. That is going to be y minus, and square root of 9 is 3 squared. And then again, I have a difference of squares. Difference of squares factors into twin binomials with opposite signs. So there's my opposite sign, square root of the first term. And then the square root of y minus 3 squared is just y minus 3. So I place that with both. And that can take a little practice, and that kind of grouping, ungrouping of subtraction, you have to be really careful with. You're not changing the value. All right, then we're taking a look at example 7. And in example 7, we do need to rearrange in order to get our perfect square trinomial. We need to kind of look at those terms and what would give us a perfect square trinomial, and that's h squared minus 4h. Notice make sure I'm taking that subtraction along with the 4h, plus 4, and then minus 4k squared. Now this is just a rearrangement of terms, but what that creates is this perfect square trinomial at the beginning. So I can think of that as a grouping, and I'm not changing the value of the subtraction there. I'm not applying subtraction to anything else that wasn't already being subtracted. So I can take a look at this, and this is a perfect square trinomial. It factors into h minus 2, that quantity squared, minus 4k squared. And of course that is a difference of squares, which factors into twin binomials with opposite signs. Square root of h minus 2 squared is h minus 2. And then the square root of 4k squared is 2k. And we have that totally factored. Make sure you're bringing your questions into class.